A humanoid robot just completed a feat that would kill most machines and freeze a human solid. The Unitree G1 robot walked more than 130,000 steps in temperatures dropping to -47 degrees Celsius. This happened in deep snow across one of the coldest regions on Earth. No heated lab, no remote control operators sitting safely indoors, just a robot and ice and conditions brutal enough to shut down batteries in minutes. The test took place in the Altai region, an area widely regarded as the cradle of human skiing, where winter temperatures can plunge well below what most commercial robots are designed to endure. Unitree disclosed that the robot logged the steps at a location with coordinates of 89.75 degrees east longitude and 47.21 degrees north latitude. The feat spanned an area 186 meters long and 100 meters wide, during which the G1 traced the outline of a Winter Olympics emblem across the snow. The robot relied on China's Beidou satellite navigation network for centimeter-level positioning accuracy. Onboard adaptive path planning algorithms enabled stable and continuous movement across uneven and icy terrain. This precision navigation allowed the G1 to create the large-scale pattern while maintaining balance on treacherous surfaces. The combination of satellite guidance and real-time computational adjustments proved essential for completing the complex geometric pattern. The machine was deliberately modified for the task, departing from its standard factory setup. To mitigate extreme thermal stress, engineers dressed the robot in an orange insulated puffer jacket. They added improvised plastic coverings around its lower limbs, a pragmatic attempt to shield joints and actuators and battery systems from freezing. These modifications represented low-tech solutions to the high-tech problem of keeping sensitive components operational in conditions that would seize the actuators of most commercial machines. The trial highlights growing emphasis on environmental durability within the humanoid robotics industry. As companies look beyond controlled indoor environments, resilience to weather and temperature is emerging as a competitive benchmark. Rival firm Deep Robotics has promoted its all-weather DR02 platform, which features an IP66 protection rating and a certified minimum operating temperature of -20 degrees Celsius. Unitree's experiment pushed far beyond this threshold, testing outer limits of survivability for a general-purpose bipedal system. The G1 is a compact humanoid robot standing approximately 127 centimeters tall, around 4.2 feet, and weighing roughly 35 kilograms or 77 pounds. Its mechanical design includes between 23 and 43 joint motors depending on the configuration, with a maximum joint torque of 120 Newton meters. The extensive degrees of freedom enable human-like kinematics and complex movements across varied terrain types. The robot is equipped with a range of advanced sensors including 3D LiDAR and an Intel RealSense depth camera and a noise-cancelling microphone array for voice control. The G1's 3D LiDAR and Intel RealSense depth cameras maintained navigation precision despite snow glare and shifting terrain conditions. The sensors provided 360-degree depth perception through integration of spatial scanning systems that capture high-precision data for environmental awareness. The G1 is powered by a 9,000 mAh quick-release battery that delivers up to 2 hours of operation and supports rapid battery swapping. The battery lasted the entire trek, proving thermal management capabilities that exceed consumer electronics. An 8-core processor controls the robot's joint systems, allowing agile movement and a maximum walking speed of approximately 7.2 km per hour or roughly 4.5 miles per hour. The robot runs on Unifo LM, Unitree's proprietary unified large model for robotics, and supports reinforcement learning for motion control and task execution. The 8-core processor ran reinforcement learning algorithms that adapted to icy footing in real time. This AI-driven approach enabled the robot to maintain balance on slippery surfaces where pre-programmed movements would have failed. The system learned to compensate for unpredictable terrain conditions during the walk itself. Unitree introduced the G1 in May 2024, positioning it as an entry-level humanoid robot with a starting price of 99,000 RMB, approximately $14,240 in the Chinese market. This pricing makes the G1 accessible compared to six-figure industrial robots, while delivering capabilities previously unavailable at this price point. The combination of affordability and advanced functionality targets both research institutions and commercial applications. Unitree ranks among China's major humanoid robot manufacturers. The company reported total humanoid robot shipments exceeding 5,500 units in 2025, according to figures released in January 2026. With over 5,500 units shipped, the G1 has moved beyond the prototype phase to become a proven platform. The robot has previously appeared in China Media Group staged boxing matches and choreographed gala performances, solidifying its role as an ambassador for public-facing technology demonstrations. Questions remain about the degree of autonomy involved in the logo carving. While the G1's ability to remain upright in shifting snow demonstrates its reinforcement learning-driven balance system, the precision required to draw a corporate logo suggests a high degree of pre-planned GPS, pathing, or human-in-the-loop oversight during certain phases. The distinction between autonomous balance control and autonomous path creation requires clarification. The demonstration served multiple purposes for Unitree. As the company moves toward a potential mid-2026 initial public offering, these high-profile tests align the company domestically with major national events like the Winter Olympics. Globally, they demonstrate hardware maturity that investors increasingly demand from robotics companies. The choice to use the established G1 rather than newer models like the H2 flagship or R1 mass-market robot indicates confidence in the proven platform. This achievement matters because most robots cannot operate below -20 degrees Celsius. Extreme cold causes battery capacity to plummet and lubricants to solidify and electronic components to malfunction. The fact that the G1 maintained functionality at -47.4 degrees Celsius represents a significant engineering accomplishment. The modifications required were relatively simple compared to the complexity of the base robot, suggesting that cold weather operation may be more achievable than previously thought. The implications extend beyond publicity stunts. Rescue missions in avalanche zones and polar research stations, and military logistics in Arctic regions, and industrial monitoring in frozen facilities all require mobile robots capable of human-like navigation. Until this demonstration, no commercially available humanoid had proven sustained operation in temperatures this extreme. The G1's Arctic marathon signals that robotics is finally escaping climate-controlled laboratories. The test also highlights China's strategy in humanoid robotics development. Rather than focusing exclusively on controlled laboratory achievements, Chinese manufacturers are conducting extensive real-world demonstrations that showcase durability and reliability under harsh conditions. This approach mirrors strategies used in China's electric vehicle market, where companies conduct attention-grabbing experiments to prove product capabilities. Environmental resilience is becoming a key differentiator as the humanoid robotics industry matures. Companies that can demonstrate reliable operation across temperature extremes and varied terrain and unpredictable conditions will have advantages in commercial deployment. Indoor demonstrations of dexterity and speed remain important, but outdoor reliability in extreme weather represents a different class of achievement. The G1 specifications support its extreme environment capabilities. The robot's force control, dexterous hands enable precise manipulation of objects with sensitivity. Combined with force position hybrid control, these hands can simulate human-like movements. The integration of AI-driven learning with robust mechanical design creates a platform capable of adapting to conditions that would overwhelm purely mechanical systems. A robot just walked through conditions that would freeze exposed human skin in minutes. The Unitree G1's 130,000-step trek through -47 degrees Celsius snow represents more than a publicity stunt. It marks the moment when humanoid robots prove they can operate in environments where humans cannot survive unprotected. Subscribe to AI Tech Academy for updates on robotics breaking through real-world barriers. Drop a comment on what extreme environment you think robots should tackle next. Thanks for watching, and we'll see you in the next one.